All right, ladies and gentlemen, I'm sure you want to see the answers to the test review you did in class today. Sorry I couldn't be there with you, but my colleagues and I were mapping out the rest of the semester to be sure we can get the most bang for our buck when it comes around to the EOC and the STAR test. I've got both of those quizzes ready to be retaken. So what I suggest you do is come into tutorials tomorrow morning. You can look over the quizzes with me. You can show me that you did that set of questions that I put in the last video, and then you can do the retake quizzes right there, which should get you extra ready for the test you're going to see tomorrow. If you can't make it tomorrow morning, that's fine. You can come afternoon for tutorials or later on in the week. So here we go. For number one, notice the like exponents. Those are like terms. They can be combined together, leaving 9y cubed plus 4y squared. Notice that these are unlike exponents and that this is an addition sign, so there's no combination that we can do there. For number two, this is a borderline trick question. Notice that we do not have like terms here. We have h to the fourth terms and h to the eighth terms. So there's no combination that can happen right there. That one is as simple as it gets. Number three, find the sum of these three polynomials. Sum means I'm adding them together. How many w's? Positive 12, positive 9, and positive 5. So that's a total of 26w. And the negative 6 and the positive 11, that's positive 5. Just combining like terms. Number four says subtract this polynomial from this polynomial. So that means either this or this. Both are the same. I've just set one up vertically and the other up horizontally. If you set it up vertically, don't forget that you have to distribute and change all your signs. So that's going to be g squared minus 5g plus 13 minus 10 plus 3, giving g squared minus 15g plus 16. A lot of people miss this type of problem on the quiz because they forgot to change their sign. If you set it up horizontally and remember to use your parentheses, maybe it's a little bit easier to see that you're going to distribute the negative. So that's g squared minus 5g plus 13 minus 10g plus 3. Once you've distributed the negative, then you can just combine like terms and you'll get the same answer. In number five, we've got powers to powers. So that's 6 to the fourth, x to the fourth, 7 times 4 is 28, y to the 28th. So remember, it's sort of like distributing the 4 as an exponent to each of the terms inside that's multiplied together. And if you put 6 to the fourth into your calculator or do it longhand, you'll get 1296, x to the fourth, y to the 28th. If you can handle number 6, you will probably do okay on the computational part of tomorrow's test. Just remember to do order of operations. Exponents first, then multiplication. So let the 5 act on the negative 2, the c cubed, and the d squared. Negative numbers to odd powers make negative numbers. So that's negative 32. Multiply the powers, c to the 15th, and again multiply the powers, d to the 10th. And now you can multiply the scary looking thing out front. Coefficient by coefficient, c by c, and d by d. Negative 8 times negative 32 is positive 256. C, or c to the first, times c to the 15th is c to the 16th powers, because I have 16 c's being multiplied together. And d to the 8th times d to the 10th. This is the case, again, where we're adding exponents now, because it's just multiplication. That's d to the 18th. And just in case you feel like I'm rushing, this is where those exponents came from. Multiplying numbers raised to powers, we can add the powers. When you have powers raised to powers, that's when you multiply the powers. In red, here we've got the powers to powers situation. And here in green, we've got the numbers raised to powers that are being multiplied. So numbers that have the same base, you can add the exponents. Number 7 is really just a simpler version of number 6. Exponents first. Negative 2 to the 5th, negative 32. 4 times 5, m to the 20th. 3 times 5, n to the 15th. Multiply the coefficients. Negative times negative makes positive. 6 times 32 is 192. M to the 20th, n to the 15th. If you tried to tuck this extra 6 or negative 6 right in here, you are wrong. Don't do that. If you don't understand the reason why, or you made that mistake, you should come see me tomorrow morning during tutorials so we can set it right. Number 8 is just a matter of cubing the side length. 6 cubed is 216, s to the 6th, t to the 12th. So by the time we get to this page, we've really left the mechanics of how does this stuff work, and we've gotten into how can we apply this to what we know about math already. 2 pi r is the equation for the circumference of a circle, but if r is x plus 3, then everywhere I see an r, I can replace it with an x plus 3. Be sure you use parentheses, because otherwise you will make a mistake while you do your distribution. 2 times 3 is 6 pi, which makes C the correct answer. Good on you if you got that right. Here it is with a bit more detail. First, substitute in the radius. When you substitute, be sure to use parentheses, especially for a binomial term. Now distribute, and then simplify the result. This is called leaving your answer in terms of pi. Yes, we could plug in 3.14 or 3 or 3.14159 and get some crazy looking decimals if we wanted to, but this looks nicer and neater. So it's preferable to leave your answer this way. I don't think there's anything this challenging on tomorrow's test, but it's a useful application and an important lesson in notation. You will definitely see a problem like this on tomorrow's test. If it helps, sketch a little picture and label it. When you add those two sides together, you get 10x plus 4. So plus what is going to get us to 16x minus 6? Well, you may as well subtract in order to find your answer. I've set it up horizontally so you don't forget to distribute that negative. 16x minus 6 minus 10x minus 4. Combine like terms and you get 6x minus 10, which means each of these side lengths have got to be 3x minus 5. Number 11 is straight addition, just couched inside a problem about the perimeter of a triangle. I see 9x minus 6. Final answer. For number 12, if you see the phrase what was added, think subtract. Distribute that negative sign. I'm telling you, those of you who understand the concept but don't pay attention to the details and miss things like distributing negatives are going to miss the whole question if you aren't paying close attention to what you're doing. Distribute your negative. Distribute your negative. Change the sign on each term. And then put them together with addition. In number 13, the first side is x. The second side is 5 less than twice the first side. 5 less than twice the first side. And the third side is 3 more than the second side. Side 1, side 2, side 3. To find the perimeter, add them up. If this is the perimeter of the square, and I want to know the side length, well, this is a bit tricky if you do it mathematically, but not so hard if you use your intuition. You know squares have 4 sides that are all the same length, so if their perimeter adds to 4x minus 16, it's not too much of a leap of imagination to realize that that's x minus 4 added together 4 times. Whether you realize it or not, you've just been introduced to polynomial division. For 15, I get 2k minus 6. For 16, you're going to have to use your powers of thought a little bit more. It always helps to draw a picture. One side is x plus 6, the other side is 3x minus 2, and the total perimeter is 64. Finish labeling your diagram. You know that the perimeter is 2 times the length plus 2 times the width, and you also know that the perimeter is equal to 64. Distribute your 2 for 2x plus 12 plus 6x minus 4. Combine like terms and solve. 8x plus 8 equals 64. Subtract 8, get 8x equals 56. Divide by 8, x is equal to 7. And then go back and check. When x equals 7, this side, the long side, is 19. And the short side is 13. 2 times 19 plus 2 times 13 equals 64. So read the question carefully to be sure you've got your answers. It does not say, what is the value of x? The problem asks, what are the dimensions of the rectangle? Which are these? Now, don't feel upset because we haven't been focusing on this over the past few days in class. You're going to be expected from here on until the end of the year to be able to call back the things you learned last semester. And a test review is a great place to practice. Number 17 is a great problem. Remember that A, B, C, and D act just like numbers. That means you can add, subtract, multiply, and divide them as long as you follow the order of operations. We're asked to solve for A, so I'm going to get rid of this 2 first. Before I do, notice this is 2 times A plus B, which is divided by C, equal to D. In order to undo multiplication, divide. Leaving A plus B divided by C on the left side and D divided by 2 on the right side. Now, how do you cancel out a denominator? Well, 1 over C times C over 1 equals C over C, and any number divided by itself is equal to 1. So multiplying both sides by C cancels here, leaving A plus B equal to D times C divided by 2. The last step is to subtract B from both sides. The problem that looks like this on the test is multiple choice. Do the best you can. We'll see it more in warm-ups over the next few weeks. Take each answer choice for number 18 and solve for slope-intercept form. Here's answer choice D, the correct answer. Negative slope, -3 as the y-intercept, and y is less than negative x minus 3. 19 has too many words for me to want to do, and 20 is a good tease for the unit that's coming up in a couple of weeks. I'll give you a hint for that one. A and D are wrong. I should be at school by 7:15, certainly no later than 7:30 tomorrow morning. So if you want a little bit more help before the test, please come in and see me. If you want to do the retakes on either of those 2 quizzes, you must bring me the problem set first. See you guys tomorrow.